Next up we have, not Sam, Alessandro, talking about MACI? Macy?
Maybe, yeah. I get that works.
Right?
Depends, yeah.
Something I've only ever seen written down.
Yeah.
Private on-chain voting.
Sweet. All right, thanks for the introduction. Right, so I'm a software engineer in PSC. Just a quick agenda. We're going to be going through what Macy is, why we think is important, how it works, and given we offer like bounties for the hackathon, what you can build with it if you wish to do so, and how you can build with it. So MACI just stands for Minimal Anti-Collusion Infrastructure, and in a nutshell, it just enables you to run private polls. The main properties of MACI are collusion resistance. So there's only a coordinator which can be certain of the validity of a vote. Receipt freeness, so you cannot really prove how you voted beyond any reasonable doubt. Privacy, just yourself as the voter and the coordinator can decrypt the vote. Even the coordinator cannot censor any vote. And while you cannot edit or delete a vote, you can just nullify it by sending a new one. And even a coordinator won't be able to produce a false output of the poll round. So yeah, we think that private voting is important, and especially we've seen like quadratic funding or voting protocols that because you give power to the people, it's so much easier to bribe, and when there is a financial incentive to do so, it's very likely to happen. So yeah, like quadratic funding, people collude, and all the funds go, instead of going to we should go to like just a few projects. And even kind of related to that, if in general, if you're voting and you maybe not haven't formed like your idea yet, if you can see how other people vote, you could technically get condition. So like you see on Twitter, everyone is voting on X, Y, Z, and you might feel, okay, maybe it makes sense to do that, but you cannot trust them with Macy that they actually voted for this project. And from a bribe perspective, why would I want to bribe you if you cannot just prove to me how you voted? So I cannot be sure of that. The architecture is divided into 3 parts. So we got EVM compatible smart contracts written in Solidity. We got a set of circuits written in Circom. These enable you to run quadratic voting and non-quadratic voting rounds. And the 2 main ones are the ones that allow to process messages and prove correct execution and tally votes for the results of the poll. And then we got like a bunch of TypeScript utilities. They can be like just primitives, like the keys that we use, the encryption algorithm, hashing algorithm, an SDK that you can use to interact or to just build something with the protocol, and then a clone of the smart contracts, which I use to do the processing which cannot be done on chain. If you do decide to hack on Macy, that's what the repo looks like. You probably won't need to touch the circuits. What you see in blue is all the JavaScript, TypeScript stuff that you can use to build on top of it. And then we got the contracts, which you might want to touch if you want to build some new anti-SIBO ways of registering to Macy, or just extend that to do whatever you like, really. Right, as a user, there's 3 main things you can do. You can see here on the top is these are Macy keys. So basically, they should not be confused with your EVM address. Like, of course, it doesn't look like that, but that's just because it's serialized. This really is a point on an elliptic curve. But yeah, let's not talk math. But basically, that's your identity. If you lose that once you register, well, it's kind of like your private key for your wallet. You don't want to lose that nor sell it. You register, you interact with the smart contract, and you send this public key. You can send votes to polls that are available. You don't need to be signed up to send a vote, but your vote just won't be counted if you don't sign up. So that kind of adds to the anonymity of the protocol. Everything that you send on chain is encrypted. So the message that you send is just random blobs of data. And this is encrypted using a share key, so that the coordinator can actually decrypt it off chain. you need to sign your vote with your private key, your Macy private key, and that way just no one else can send a vote on your behalf. Finally, once everything has been processed and the results tallied, you can just verify them on chain. This is what the coordinator does. So just imagine we run around, everyone voted, we're all happy, and the poll is ended, no more votes are accepted. The coordinator then is in charge of taking all the data from the blockchain, merging these trees. So we use some sort of like Merkle trees-like structures, a bit more optimized for user usage, but they require some extra step on the coordinator side. But anyway, we just get all the data, we save it locally, and basically generate a representation of the poll in TypeScript. And you can use these to process the messages, and then you'll be able to generate ZK snag proof using these circumcircuits. Because of the constraints of the circuits, which can be quite a lot, like in the millions, we do stuff in batches. So you would submit every time a proof that a batch of messages has been processed correctly. Once you process the messages, submit the proofs and commitments on chain, we can tally the votes, and again, generate the proofs, submit on chain, and that's when you as a user can just take the public data that is made available to you and just verify that everything looks done correctly. There are some trust assumptions, so I mentioned the coordinator quite a lot. We do assume that this is honest, but yeah, they could decrypt messages, sell them if they wanted to. They could just be like, hey, I don't want to conclude the round because whatever reason they have, or just delay. Or they could collude with bribers. There will be work in the future to hopefully get rid of a coordinator, but at this time it is needed. But the good stuff is that they cannot really censor your votes. So that is thanks to the smart contract. So all of the votes you send are stored in this Merkle tree on chain. So they just cannot avoid not processing some of them in the circuits. And as well, they just they cannot perform any incorrect processing. The source of truth, we talked about this Merkle tree. So you have a root on chain. It can be verified that everything has been included. We record for each poll however many users signed up, however many messages were sent. So if you're a coordinator, be like, right, I'm just gonna, process 99 out of 100 messages, they won't be able to submit the proof on chain. So you as a user would know that something is up. So yeah, this is right. For the hackathon, just some ideas of what people can build. There's a few majority funding apps that are already built on top of Macy, like most notably Still Fun. So yeah, you may choose to build that or just try something new. We think could use for like DAO toolings. That's something we've not tried yet ourselves. Or Gatekeepers. So basically, it's just the way that you prevent users from signing up to the contract. Just something simple like a front end for like voting on which movie to watch at work, and if you want to do it privately for whatever reason. Or yeah, some stuff that would be very useful to us and to the project is also how to Dockerize Macy so that it can just be run on any system. There's a discussion. I'll share this later, so you can just click on that and you see all the projects that we suggest, but feel free to really do whatever you think Macy can be used for. Just quickly, how you can build on it. So here we're looking at how you will interact with the smart contracts and the stuff that you might want to change. Just as a user, you're the green one, you interact with Macy and you can sign up. There's a contract here, the gatekeeper, it just says, right, can I sign up? Yes or no, whatever reason, proof of personhood, owning an NFT, you choose it. Voice credit proxy is like, how many voice credits do I get? The voice credit is just the representation of your voting power. So user, you sign up, this data is returned by the smart contracts, which you may extend as you wish, and the data is stored in the Merkle tree. And then the coordinator comes in, you deploy poll. When you deploy poll, there's 3 smart contracts would have been deployed. You as the user cannot really have to bother with the poll. That's where you submit your vote. The coordinator will then go into processing the messages using the message processor and tally for submitting the tally results and the proofs. And then as a user, just go and verify that. So that's some example of some code that extends MACI. So this is like a very simple quadratic funding protocol. You just see here, just extend MACI, call the constructor, save our many variables you need extra. Because it's quadratic funding here, we just need a token for people to send money. And as well in the sign up, we override the function. So while we call the original sign up function and trust it to do whatever it's supposed to, we can also add extra logic, like taking like a contribution from the user and storing it in case there's need for a refund. As well, here, that's where you deploy the poll. If you want to do anything extra on it, you can just extend this function, store the addresses, and in this case, I've added a initialize function to the tally contract because I wanted to do more stuff, and that's where you can do it really. Again, here, just a function that you can use to like claim funds. So we added the funding on top of voting. You as a project you send the proof that okay, this is the proof that this project vote option index got, I don't know, 50 votes, so maybe 50 token, whatever. And here, if the proof validates, the tokens can be transferred. That's just an example. We do have like Frontend built on top of it as well. So you can just go and copy like hooks and whatever you think might be needed. There will be links at the end. Yeah, just the bounties. We had 2K divided into 3. So first one is 1,000 and it just goes down until 250. We have a booth downstairs, so feel free to come down and ask if you need help, even just validating an idea. Yeah, just to conclude, we are focusing on this because we really believe it's important. We're seeing a shift into like a digital world, and hopefully voting can be done in a private way, and we hope the Macy can make a difference. It's not perfect, far from it, so that's why we're here, hackathons, or in general, if you don't want to hack here, you just want to contribute, we're always open to enable people to do whatever they think is best and try and help us. Everything we do is open source, so yeah. Just a link to join the Discord. But yeah, I think that's it really. Yeah, there's some links. I'll share this later. But if you have any questions, we can just go through them now.
Thank you very much. Does anyone have any questions? Yes. That's a quick hand.
No, I will be quick here. What's the end game for Macy?
Well, I think in our roadmap, right, Sam, we got elections at some point. Why not? Maybe like a small country, just to start with. But, I think ideally this could be, when improved enough, could be used for like elections, yeah.
And the follow-up, in Istanbul, the Odysseus made a talk and then published on Moloch DAO research on different private voting protocol solutions. How you define or navigate yourself within the so-called competitive open source landscape? Like where you fit in, and how do you see your trajectory? Like what will be different in your case instead of whatever Aragon ZK research is doing and others?
Yeah, I mean, I think we are one of the few, if not the only, that offers the bribery resistance by incorporating ZK. I'm not really familiar with all the other projects. I did have a quick read through that. But yeah, I mean, we're actually working on this. I'm not sure whether these other projects are, but we love for like collaboration. So if Macy doesn't make it, we hope that we build something that any of these other projects can pick up, or the opposite. Like it's a public good in the end. So yeah, we, calling it competitors or anything is just shouldn't. Yeah, but yeah.
if I want to organize a movie night with 20 friends,
Yeah.
how much does a vote cost about per person?
Very
Do you have
little
Any
now.
idea?
Yeah, I think now it's. Yeah, if you deploy an Optimism Arbitrum now, it's like a cent, maybe. Yeah, it'll cost you to deploy the contracts, yeah, a little bit more. But you ask your boss to do that, you just you just send the vote. So yeah, a cent, 2. I don't know.
Nice.
Mhm.
Yeah, if the vote is a transaction and you docs the sender by the result, I mean, you see a transaction and you see the outcome, how the votes changed, like the or you don't see the results.
You
immediately.
you wouldn't see that. No. As a result, what you see is like, I don't know. Let's say there were 10 options. You just see like however many votes each option got. You don't really see like how each vote was decrypted, but you can be sure that it was done correctly because of the TK part.
But you can request the result of the poll. Like,
Yeah.
For how many votes, and you can check it immediately after the transaction went through.
Well, no, because the actual results would be at the end. So like there's a voting phase, and then there needs to be certain processing done. But yeah, like in the end, only the coordinator could go and make a connection between that. We assume it's honest, but one way is also you just, because you can vote from any address, you just create a new address, a new wallet, and you just vote from there. That's it. That's your anonymity as well.
Okay, so you only see the result of the poll at the very end. Not,
Correct.
Okay, yeah, that's clear.
Thanks. Thanks for the talk. I have one question around kind of the coordinator. Like, what's the main reasoning why it's like off chain right now? I mean, one obvious reason might be like historical gas costs, right?
Mm-hmm.
But I can imagine that if we like we're doing everything that the processor is doing through another contract that like anyone could call, say like after the round is concluded to compute the results, we could probably do something like that at like for like a $50 or like $100 on Optimism. I don't know, like, or is there other reasons why it's happening off chain?
That's because of the privacy of the vote. So the vote is encrypted, and if you were to process it on chain, then everyone could see the vote being decrypted, right? So so that's the reason why maybe like if you introduce like fully homomorphic encryption at some point,
I see, yeah.
you might be able to do that, but at this time you want the coordinator to decrypt the vote and process the content of it. And if you do on chain, then it would just say, right?
So that would only work with like this homomorphic encryption thing eventually.
I guess I'm just assuming it's not something we tried. I know zero about full homomorphic encryption, but I just assume that could be something. But yeah,
I see. Thanks.
And I'm not sure. It might be still worth doing on chain. You could still do it off chain and verify still in a snark to make it more. But yeah, if anyone could do it, because you process the data while it's encrypted, then you wouldn't need a coordinator.
Exactly. Yeah.
So yeah.
Yeah, it might be nice to get there eventually. Of like.
Do hope so.
Yeah.
Actually, I remember one. So I seen recently lots of proposals on forum on using Macy for like retroactive funds and stuff like that. And then I remember one thing which you don't talk much, but it's interesting to think about, like what's the kind of planning horizon for these use cases or these solutions to be really implemented, well tested, so then we can use them. And why I'm asking here, because once, I don't know, like almost 2 years ago, I was talking with Aztec, and they were saying, yeah, in a year, everything will, or it was scroll, something like that. And then a year passed, and still like, and this is okay within their R&D. So the question is like, all those use cases that you're pulling kind of online and making them public and going forward, what's the roadmap for the real implementation?
So we do have a demo for the RPGF for Optimism. I mean, it doesn't have to be Optimism, but it was kind of tail of them. We just run like a test round. A few people tried from the foundation as well. There's a proposal on the forum. Feel free to comment there as well if you have any ideas of improvements. But it's there. Like it's not perfect, but it's a demo, and we do hope that it might be used, whether it's for the next optimism round or like whoever else wants to do like retroactive public funding. But in terms of like public fund, I mean, quadratic funding itself, it is being used. Like CLR Fund has been running rounds in production, just most recently in ETHDam. So yeah, it is being used. But yeah, for the RPGF, it's maybe used, but the demo is there.
That's all we've got time for, I'm sorry.
No.
Thank you very much for your time. That was excellent.
Thank you.